Yeah, so this is exercise 2, where we're going to write a function. Now we are going to write a function. Part of this assignment, the code is pre-written, but you would have to enter it into TI portal and compile and so on. So if you look at the assignment here, so program a function and also learn how to make a user data block and call the function with arguments, inputs and outputs, and a user data type in assignment 3, the last one, because then the function we are making is going to be optimized. And then we have to make a POU with the organization within TI portal we are going to look at later. Okay, so first assignment, what we are going to use is something called Newton method to find the square root of a number. And that's an iteration or a loop that we have to do, and a loop can be more than one thing. So there are going to be 4 loop structures that in this assignment, and the first one is a for loop with an increasing argument, increasing index. Yeah, and calling the function and so on. Okay, and then the assignment 2 is to modify it to a decreasing loop, and a while do loop and a repeat until loop. So use all the looping structure within the structured command language, SCL, and test all these functions. And the documentation is program listing. You get a program listing here, but don't copy in what's in this document in here. Take a snag of your program and put it in here. And that was 2, and assignment 3. Then we are going to optimize this function and test for errors. Or first, a user data type. We're going to program a correct function that returns only one value. And as this one is going to return the radix itself and an error indication, say it's wrong or okay, we need a user data type. And we have to look at that. And that has to handle a 0 argument. The square root of 0 is 0. The algorithm doesn't work for 0, and negative numbers doesn't have a square root. It's as simple as this, and it should return an error, and that's an error, and then a not a number or return value. And testing again, test all function or this function in the program. Test by calling it the program square root. User data types are here. We're going to look at it in TI portal, and this is the user data type or what's in the data type. Okay, here's a little background. Here's the function we are looking at. X squared minus a is 0, which means this x has to be plus minus the square root of a. And here is, this uses some Taylor series expansion around the solution here, what it is, and then how it's calculated by convergence to a number. And just putting these, or this function up here, this function into this one, we end up with this function. That the next result that we are looking, that I'm getting closer and closer, hopefully to the square root, is going to be the last one or the first one. The first one we need a seed because we don't know what is when we have to start somewhere. And then the xn plus 2 is going to be the one we calculate first, and so on. And then we do the iterations until we are satisfied with this one that's close enough for the square root. And the thing is, how should we find out when it's good enough? Then we just say the difference between what they calculated the last time and what they calculate now is below a certain number, because then we are finding the minimum of this function where the square root is. Yes, and here is what we call a pseudocode for the algorithm, but in program tips you get the entire program. Here are inputs for this square root increase, have inputs and outputs, and here's an information output of an array. As we do this loop here, every time we calculate a new number, we put it into an array, and Just you can see how it's approaching the square root. A function in IEC norm cannot have more than one output. It's the function itself. The here it's void. But Siemens allows us to output more values than one. Okay, and here are some temporary ones. Internal array. This one is just copied to the out. And then some constant. The limit we are looking for is 10 to the power minus 6 with 6 decimal numbers. Which is sufficient. We say that's sufficient for a square root function. Okay, and here's the code. This is something that's entered normally when you write code, who has written it, SI, and what inputs you have and outputs and so on. And here's the code with a for loop is that we just use some temporary values in turn, and they should have been switched because it should be TIIX is 0, and here should be TIIX in instead of 0. So this one I could have omitted. But when you adjust this stuff for later, you should maybe keep it, because for the while do and repeat until, you have to count this index for yourself. But here the for loop just resets it to 1 and goes to max index. That was 19 here. And here's the calculation, the formula that we had. Half of this expression. Let's see if we have it here. And here's the seed, the guesstimate. Let's say if we take in the square root of 9, we know that it's 3, but at least we know it's less than 9, so our first guesstimate could be 8 when we start at it. A starting point could be half of the radicand, what you are looking for radix of. Okay, and then you just go through here. Then you output information. Yes, and here there was the information output in the arrays, and then we have a cost function that says, okay, if the last iteration is less and the difference between the last and the next last one is small enough, I'm done, because then I'm approaching the 0 here. So I'm close to the 0. So my cost function says that I'm close enough. And then I abort the loop, exit the loop, and go down here and write that result. And if not, I have to update my seed with my new guesstimate, with my better estimation. Okay. Then there's a user data block you can see here with the parameters. These up here, they're going to be parameters for the function you make. And here is the function call where you see the parameters, input and outputs. The arrows to the right are the outputs, and the colon equal, that's inputs. That's assignment. And here are the results. And here is the last assignment, because this is from the solution, where it's optimized with only one input. And here is the square root, the built-in square root in TI portal. That's about it. So if you now go and look at TI portal itself, it's the assignment 2 square root. Here is the function, the FC square root in assignment 3, and here are these. And the four. This one is the first one. This one was in the document, and you have to make these yourself or adjust them to this. And here is the program where they are called. I can open that. That's what was in the document. And if the instruction, if you look at the math instructions here, you should have the square root somewhere here. Square root. That's this one. That's built in. And here is the instance data, no, the user data block. So you would have to program. It's basically just to program that one is right click, add new block. Data block, give it a name, db square root. Okay, and then you would have to enter this because it's empty when you start. The function is also empty. So for the function, you would have to to, if there was the for increase, open that one. So you would have to write in these values here, and then you have to enter this code. Okay, and then it's the program square root. Will we open that? Yes, we have already looked at that. And that has to be called in program main. This one. And for the last assignment, there was the user data type. And they are down here, PLC data types they are called. And UDT square root looks like this. Again, add new or right click, add new data type, given this name, and so on. Okay, yes, I can minimize that. So that is the assignment here. So okay, the exercise 2 is about writing a function, and the function needs somewhere to store the data, and we use then a user data block to do this. And if you use function like this, the function always has to save data somewhere. So if you want to use a function as a standalone with input and outputs, you have to make a user data block, or you could use global memory, but the latter one you should avoid. You use a user data block. A user data block is global too, but still it's better than global memory. And then the function itself is going to just find the square root of a number. Of course, we have a built-in function in TI Portal. It's going to find the square root for us, but we have to program it ourselves and then make an optimal function at the end. And then we are going to make a function that only returns one value. And as there's going to be an error indication, a true, false, true if it's error, and false when the number that you return is okay. And the number itself, we need a user data type with 2 elements in it, a Boolean one and then the radix itself. Yes, and the hand in is just a copy code into a document and hand in.